Okay, I want to look at this example right here. I want to say we have a circle, and the circle has a chord in it. This is any chord. We'll call it AB. Let's say that the center of the circle is O, and the midpoint of the chord is M. I'm going to say, okay, I'm going to draw a line from the center of the circle to the midpoint of the chord. And then I want to investigate the properties of this line right in here, the OM line. Okay, now because I've drawn this, let me call this point here P. That'll be the point where this line intersects the circle. Okay, now I can draw the radius of the circle if I want. I can draw it from here. I don't want to use that tool, undo drawing. Draw the radius of a circle right here and draw that line right there. I can draw another radius of the circle here to here. Okay. Now, I've said that this is the midpoint of the chord, this M, so that means that this line is equal to this line. Since both of these red lines are radiuses, I can say that this line is equal to this line. And of course the line OM equals itself. So I have two triangles, and these two triangles are congruent by side, side, side. Okay, side, side, side. So those two triangles are congruent. And that means that this angle here, the angles on either side of M, that these angles are equal. But because AB is a straight line, and the angle subtended by a straight line is 180 degrees, the only way that these two angles can be equal is if they are both equal to 90 degrees. So I have then that both of those angles are equal to 90 degrees. So what we have is that if we have a line here, OM, which intersects the midpoint of the chord going from the center of the circle, that at the intersection of these two lines, the chord and the line OM, is always going to be at 90 degrees. So what do we have then? What we have, well, is we have that because this line is equal to itself, and because this by definition is the midpoint of the chord, so I have that, let me draw a 4 there because that's where we're at right now. So this line equals that line. This line equals to itself. This angle is equal to 90 degrees. So we have that this triangle is congruent to this triangle right here. Okay, let me draw straight lines for those. This triangle right here is congruent to this triangle. Okay, so that's pretty interesting. In particular, notice that we can say that the perpendicular bisector, because that's what this line is, it is the perpendicular bisector of this chord, that the perpendicular bisector of any chord will go through the center of the circle. Now, that is a pretty interesting result, that the perpendicular bisector of a chord goes through the center of a circle. Because what can we imply from that result? Let me draw another circle. Okay, here's another circle. Okay, and I will draw any chord. Let's say I draw this chord here. I'm going to draw another chord. Let's say this chord here, like that. And if I draw the perpendicular bisectors of those two chords, so say the perpendicular bisector of this chord looks like this, comes through there. The perpendicular bisector of this chord looks something like this. That the perpendicular bisectors of any two chords, in fact, will determine the location of the center of the circle because they each must pass through the center of the circle and they intersect at the center of the circle. So that's an interesting result, and we'll be using it a little bit later.